We are.
Oh yeah. No, I got that.
All right, so the drawback to doing this, as I told you, is that I have to stay in a little restricted area here, okay? So pretty much here's where I'm gonna be the whole time, all right? Which is a bit of a pain, but it is what it is. All right, so what I need now.
Well, I do. My BMW doesn't have a camera, and it's like it's black and white. Do I drive my? I thought you were flexible. I thought you were gonna be like, yeah, I have a better car than you. No, I need to buy a rear camera. I need to get a rear camera, but I have like no money. And like that's the thing. Yeah, no. BMW yourself.
Come on.
No.
There we go. Okay, what were we talking about last time? Rational functions. The steps to graph these, right? What are the steps? Let's list down the steps. We ended class with that last time, and then we're going to do our first example, okay? So the first thing we do is what? X-intercepts. Now I'm not going to list out how we do it. I'm just going to remind us. X-intercepts first, then vertical asymptotes. We talked about that last class. Next step, horizontal asymptotes. Fourth step, sketch the information that you just got. And then 5 test points, and I didn't get a chance to explain that. And then last, final sketch. Final sketch. All right, those are the steps we're going to follow, all right? Example number 1. We'll probably be able to do 2 or 3 examples today. That's it. These problems take a long time, right? So here's our first example. Let's sketch the polynomial function f of x equals, man, all these markers suck. Let's see. All right, let's start with x plus 3 over x squared, let me go minus 1 plus 4, plus 3x minus 4. There we go. So this is a rational function. It is a polynomial divided by a polynomial. So we're going to go to step number 1. We want to first find where this graph hits the x-axis. So to do that, step 1, x-intercepts. How do we do it? In your notes? Set the numerator equal to 0. What's the numerator in this problem? X plus 3. So set that equal to 0. And notice that this is just an equation, right? We just solved this equation. So to solve this, move the 3 to the other side, subtract 3 on both sides, and you get x is equal to negative 3. Now I will remind you of what this actually is. This is a point, right? This is a point on the x-axis, right? That's what that's going to be. When we draw this at x equals negative 3, we're going to put a dot there, and that's part of our graph. Step 2. Step 2, vertical asymptotes, right? So step 2, vertical asymptotes. How do we do that? How do we find the vertical asymptotes? Set the denominator equal to 0. So we're going to take the bottom of this and set it equal to 0 now. So we take x squared plus 3x minus 4, set it equal to 0, and that is a quadratic equation, which we have studied already in this class. We talked about solving quadratic equations. How do we solve that? You have two choices. What are they? Quadratic formula or factor it. You can either try and factor it or you can do quadratic formula. So if I try factoring, I'm going to use that little thing here where I put a 1 here and I multiply and I get negative 4 up here, and then this would be positive 3. I have to come up with two numbers that multiply to be negative 4, add up to be positive 3. What are they? Two numbers that multiply to be this, add to be this. 4 times negative 1. Okay, now we've been through this, right? We've been through this. So I'm not going to go through in detail again. But let's just get to the factored part. It would be x plus 4x minus 1 right here. And then you set each of these factors equal to 0. And you get x is equal to negative 4, and you get x is equal to positive 1. So earlier in this class, I tried to stress to you how important you being able to factor and solve quadratic equations is, right? It's like this theme that just doesn't go away in this class. So we have done that. We've solved the equation. We have two answers, right? Two answers. Now, I'm going to, just like I did over here, I told you this is a point on the x-axis. We need to understand what these are. These are vertical asymptotes. And if you remember from class last time, these are vertical dotted barriers. Those were those vertical dotted barriers. And remember, your graph, when it goes towards those, either has to go up or down. Any questions? All right, step 3. What's step 3? Horizontal asymptotes. All right, for horizontal asymptotes, this is the weird one. This is the one that's strange. And I told you in class last time, there are 3 different cases you could have when you get to horizontals. So what we do for horizontals is you look at the degree of the numerator. Okay, the degree of the numerator is equal to 1, right? What is the degree of the denominator? 2, right? Degree of denominator is 2, right? And what you do now is you compare these two numbers and you say which one is bigger than the other, which one's smaller. So would you all agree that the numerator's degree, the 1, right? Let me say, yeah, the 1 is less than 2, right? The 1 is less than 2. Or you could say that the numerator's degree, so the numerator's degree is less than the denominators, right? The numerator's degree is less than the denominators. So go in your notes from last class. There were 3 different cases, case A, case B, right? A, B, C, or did I do 1, 2, 3? A, B, C? I'm going to write those. This is going to be off the camera, but it should be in your notes. So what was case A? If the numerator is less than the denominator, that was case A? What was case B? Equal? No. Numerator is greater, denominator. And then case C was they're equal, right? Okay, so what case are we in here? We're in case A, right? This is case A. The degree of the numerator is smaller than the denominator, case A. So this is case A. And what happens in case A? What do I say? Y equals 0. is your horizontal asymptote. Can y'all see this okay? Okay, I'm sorry, it's best. Normally I can get the projector and I can tilt it down where it's white all the way down, but I have to come back in here and get a ladder and adjust something. Okay, good? Now let's talk again. What is this on our graph? Okay, what is this? Well, this is our horizontal asymptote. And the way I told you in class last time to think about this is that this is like a magnet. Oh, sorry, it's a horizontal line. Okay, horizontal dotted line drawn at ends only. So the horizontal asymptote tells you what's happening to the graph way out to the right and way out to the left. It tells you nothing about what happens in the middle, only about the ends. All right, and then it acts like a magnet. It acts like a magnet, right? And it pulls the graph towards it. Pulls graph to it. All right. That's where we are so far. Good? We have the x-intercepts. We only have one x-intercept. We have the vertical asymptotes. We have two of them. And we have a horizontal asymptote of y equals 0. And now we're going to go to the next step, step 4, which is to sketch the information we have. So we're going to try and draw a graph right now using everything we just got. Oh. Let's do it right here. So I'm gonna draw a graph. Here's my axes. All right, let's start with the first step. The first step, we had an x-intercept where? -3 on the x-axis, right? So I'm going to do this in a different color. The blue is going to be our graph, all right? It's going to be the picture of our function. So 1, 2, 3, -3. I actually have a dot there, right? All right, that's the first, yeah.
How does that work if the horizontal asymptote is at y equals 0?
You'll see.
Okay.
Yeah, you'll see. Because the horizontal asymptote only affects the edges. It doesn't affect what's happening in the middle. All sorts of things can happen in the middle. The horizontal only tells you the end behavior.
Okay.
So you know, remember on the polynomials we had that table that told us like it went like that or like that or like that or like that? But in the middle it was like we don't know. Same thing here. The horizontal is telling us what happens out here, but it tells us nothing about what happens here. Okay. So if we actually touch the y-axis, it's okay.
Oh, okay.
Yeah. Okay, next piece of information was what? Verticals, right? We had two verticals. Where were they? -4 and 1. So if I go to -4 and I go to +1, what am I going to draw there? Which way? Vertical. Straight up and down. I'm going to draw vertical dotted lines. And what I know about these vertical dotted lines, they are not part of my graph, right? Like they actually, they're not part of the graph, but they actually help me in drawing the graph because my graph cannot cross those, right? They're barriers. So when my graph gets to them, my graph either has to turn up or it has to go down on each side, all right? All right, and now finally the horizontal asymptote, right? Which was y equals 0. So y values are up and down, right? Y equals 0 means you don't go up or down. Your y equals 0, it's actually the x-axis, right? But I'm supposed to draw a horizontal dotted line, right? But only at the edges. Do not draw a horizontal line all the way across. Do not do that. just come out here to the left and over here to the right and draw a horizontal dotted line. Do not draw it all the way across. What did I say? Do not draw it all the way across. That's 3 times I've told you that. All right? Don't, because that will actually cause confusion. You will confuse yourself, because then in the middle you're starting to do things and you'll think you can't cross the green. You can cross the green within the middle. You just can't, at the edges it can't. All right? Well, at the edges it gets pulled towards it. All right? All right, that's all we have. That's it. That's all of the information we have about the graph, right? What we need to do now is get more information so that we can draw a better picture. So we are at step 5, test points. And I did not explain this in class last time. I just told you when we come back next week, I'll explain what the test points are, right? So here's the way test points work. What you're trying to do is get more points so that you can draw the picture. Right now we don't have enough to draw anything. So the way we do test points is this. I need to just kind of figure out, I'm going to pick some values on the x-axis that I'm going to take and I'm going to plug into the function. I'm going to figure out whether or not the points up here or down here. We're going to figure out where they are. But we need to figure out what point should I pick, right? What should I pick to test? So what we normally do is this. We look at the x-intercepts and verticals, okay? Count the total number of x-intercepts and vertical asymptotes. Okay, how many do we have? Let's count how many x-intercepts we have, how many verticals. So 1 x-intercept, 2 verticals, right? That's a total of 3, right? That means we will need 4 test points. So however many x-intercepts and verticals you have, you will always need 1 more than that number of test points. So there are 3 in this problem, right? That means I need 4 test points. Right? We need 4. That's always going to be 1 plus this. Right? Take that number, add 1, and that's where the 4 comes from. The question is, where do I pick them? I can pick 4 test points anywhere I want, but the way I pick them is important as well. What you do is this, pay attention, because it's hard to write this on the board. It's easier for me to just verbalize it. What I'm going to do is I'm going to look at my verticals and my x-intercepts. I'm going to start at the far left, and what I see is a vertical, right? One of my test points needs to be to the left of it. So I need something on that side. So any number I want over here, anything, can y'all think of any number over here? -6, -5, -7, -10, any number you want. It just needs to be to the left of this. The way I'm going to do this is this. I'm going to put a little X here. Don't put a dot. Don't put a dot, because if you put a dot, you might think it's part of your graph. Okay? I'm just going to let you know that I'm going to plug in -6 here. I'm going to circle it so that you know it's a test point. All right? So -6 is one of my test points. Okay, I need 3 more. To get the next one, right, we chose this vertical here, and we went over here. Now, do you see that to the right of that I have an x-intercept? I need something in between these. Something in the middle of these. So what's a number in between -3 and -4? -3.5. See how I put an X there, not a dot? -3.5 is another test point. I realize this sucks, okay? Long, tedious problems, all right? Long, tedious problems. So I have a second one. So in between these two. So I got myself to here. Now I look to the right. I have a vertical here, right? I need something in between these two. Any number between -3 and, this was 1, right? That's a 1. Okay, any number between -3 and 1. -2. What else could work? -1, 0, right? Could I use 0.2796? Yes, right? As long as it's between here and here. I think the best number between these two is 0, because it's easy to plug 0 into something. So I'm going to pick 0, put a little x there, there's 0, that'll be here. But again, you could have used -1 or -2, totally up to you. Okay, I just need one more, right? So I've got something to the left of this vertical, something between these two, something between these two, one more thing to the right of this. 3. There they are. All right. So I've got 4 test points. And now what I need to do is actually test them. And that just means take these and plug these into the original function. The original function that I gave you, which I've erased from the board. So I'm going to have to put it back up here, okay? So my original function was the function f of x equals x plus 3 on top, right? And then it was x squared plus 3x minus 4, right? Yeah. Right, that was it? Okay. That was the original function. And what I need to do is take these points and plug them into this one by one. All right? Yes?
Is there an easier way to do it, or is that just the way?
Easier in the sense of plugging these in.
Yes, sir. Yeah.
There is a slightly easier way, which I'm going to show you. Let me plug -6 in first, and let's just see what happens. And I'm going to show you a slightly easier way. Okay, so I now need to figure out what happens when I plug -6 into that function. So I'm taking -6, plugging it into the function. So everywhere I see an x, I replace it with -6. Get -6 plus 3 on top. On the bottom, -6 squared plus 3 times -6 minus 4. On the top, I get -3, and on the bottom, let me see, -6 squared is 36. I take away 18, and I take away 4. Almost there. -3 on top, 14 on the bottom. Follow or no? Yes? So that means that when I'm over here at -6, right? When I'm over here at -6, I'm supposed to, that's my x coordinate. My y coordinate is up or down? Where's my y? -6, and then put a dot above here or below here? What's the y value? What did we get? Right, this is what we plug in for x, and it spits out what? A negative number, right? It's a negative number. So shouldn't I have a dot down here? Move it down? Yes? Why are y'all looking so strange right now? Are y'all okay? Everything all right? It's Monday? Okay.
I only got 2 hours of sleep, so.
Okay. Okay. So when I plug in -6, I'm getting a negative answer, right? Yes. Which means that when I go to -6 on my x, my y value is down, right? Down. So I would put a dot down here. Now I'm supposed to go down, what, 3/14? That's really small, isn't it? Like really, really low. Actually, we don't care how far down you put the point because we're sketching this. And just like polynomials, we didn't know how high or low they went. Remember the polynomials? We just knew that they went up, down. Same thing here. We don't really care about being, oh, you got to be kidding me. I got to be quick or I got to log back in. Come on. That's why I hate using these computers. Ah, good, good, okay. Okay, so I'm going to just go over here, -6, and I'm going to just go down, and I'm going to put a dot, and I'm going to put it in blue because it's part of my graph. So I'm just going to put a dot down here. All right, got it? Now, let me show you a slightly faster way of doing what we just did. You know how we took -6 and plugged it in here? And at the end of it all, we got a negative number? If, instead of doing that, I'm going to put it right here so I can fit it here. If instead of doing that function, you take this and you write it with its factored form. So remember we factored that quadratic? And it didn't it turn out to be x plus 4x minus 1? right? That's what we did when we factored it earlier. Watch, if you plug -6 into this now, you can do it in your head without writing a single thing down. Watch. What's -6 right here? -6 plus 3 is -3, right? Now all I care about is the fact that it's negative. So do you all agree if I plug -6 in here, I get a negative on top? Okay, I'm going to put a little negative sign, circle it. That's a negative number on top. Divided by, okay, now put -6 right here. What's -6 plus 4? -2, so I get a little negative number right there. Times, now -6 minus 1. What's -6 minus 1? Minus. -6, take away one more, you get -7. That's a negative number, right? You following me? What do two negatives multiply to be? Positive. So you have a negative on top and a positive on the bottom, and then what's a negative divided by a positive? Negative. So at the end of the day, you have a negative number. I don't even care about the fact that it's -3/14. I just care that it's negative, because that means when I go to -6, I'm going to put a dot below. If it had turned out to be positive, I would put it above. Understand? It's just faster that way, because all we care about is positive or negative. You can't do that. You can't do that when you have addition and subtraction. You're not allowed to do that. You can only do it when you have multiplication and division. Does that make sense to you? Let me see if it does. If I tell you I have a positive number, and I tell you I subtract from it a positive number, can you tell me whether or not the answer is positive or negative? Can you tell me? You can? If I have a positive number and I say subtract a positive number, can you tell me if it's positive or negative? You can't, right? Because I could say 7 take away 5, that's 2, right? But I could say 5 take away 7, that's -2. So when you have subtraction or addition between two numbers, you can't figure out what the signs are. Does that make sense or not? Okay, but this, by factoring it, everything is multiplication. And when you have multiplication, you can always tell what the answer is. Two positives are going to multiply to be positive. Two negatives multiply to be positive, and if they differ in sign, they multiply to be negative. All right, what do y'all want? Do y'all want me to stick with this method where I plug everything in, like get the exact answer, or do y'all want me to do the positive negative? What's that? Exact. 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 Okay, positive negative? Okay, so it's about, so you on the test, or homework, you do which way you want, okay? Let me do, what I'll do, why don't I do this next one with the positive negative, and I'll do the last two by plugging in. So let's try the -3.5, okay. So look right here. If I plug -3.5 right here and add 3, what do I get? -3.5 plus 3. You get a negative. So I get a negative on top. Okay, what's -3.5 plus 4? Positive. Times, what's -3.5 take away 1? Still negative. Okay, on the bottom, positive times negative, negative. And negative divided by negative is positive. So when I plug in -3.5, I get a positive answer. So when I go over here to -3.5, which is right there, right, I have a dot where? Above. How far above? How far above? Doesn't matter. Just put it up here somewhere, okay? Let's try and plug in. Are there any questions on this positive and negative thing? Do you want me to do it again, positive, negative, or do you want me to plug in? Let's revote. Positive, negative, plug in. It's okay. All right, we got about half and half. All right, let me plug these in. Again, you do what you want. F of 0. Let's plug 0 in. We're actually going to plug in precisely. 0 plus 3, 3. On the bottom, 0 squared plus 3 times 0 minus 4. So you get 3 on top, and on the bottom these go away and you just get -4. So 3 over -4 is a negative number, right? So at 0, I put a point where? Below. Anywhere I want. We're only 25 minutes into the problem now. Okay, last one. Plug in 3, right? Plug 3 into this function. I'll do it up here. F of 3, and we're going to do the long way here. F of 3. So on top we get 3 plus 3 over, then we get 3 squared plus 3 times 3 minus 4. So on top we have 6, and on the bottom we have 9 plus 9 minus 4. This turns out to be 6 over 18 minus 4, 6 over 14. I'm doing that fast, but, you know, plug in. The important thing is that our answer is what? Positive, which means when I go to draw, put a point, it's going to be at 3 above the x-axis. Isn't this pretty? All right. At this point, we should have everything we need to draw the graph. We've got the x-intercepts, vertical asymptote, horizontal asymptote, and test points. I'm telling you that this should be enough. We should be able to draw a pretty accurate graph. So now what you have to use is your head. You have to use your brain here, all right? You have to think about what this is going to look like. So I always like to start here at the far left point. That's where I like to start, this far, far left point. And what you have to imagine is that you're going to get your pen and you're going to start drawing this graph. And you first are going to go out to the left and draw it, and then you're going to go out to the right and draw it. So as I draw it to the left, can somebody tell me what I must do as I start drawing this way? So do I need to go like this? Should I go up like that? Why can't I go up like that? If I go up like this, won't I cross the x-axis? And I only have one x-intercept. There it is, right? That's the only place I should touch the x-axis. So do y'all agree I can't go up? Do y'all agree I can't? Well, can I go down? I could go down, right? There's no problem. But there's something important telling me exactly what I have to do. What? The horizontal asymptote. This green dotted line acts like a what? Like a magnet, and it pulls my graph towards it, doesn't it? So when I draw this, my graph must get pulled up towards that and then start to try and flatten out. Y'all see it got pulled? Yeah?
Sorry, I'm just trying to figure out how the graph actually moves, I guess. Because in my small brain, I'm just trying to think, like, why does it go down, like, both ways, or does it go, like...
What, this way?
Yeah, yes, sir.
Well, we're about to find out what it does.
Oh.
Yeah.
Right.
So let's draw it to the right. No, you can help me. I'm going to draw it to the right. Okay?
Yes, sir.
All right. It's almost like we're back in kindergarten. We're trying to connect dots, okay? We're trying to connect this